So far, I have introduced about the concept of stress and strain. Here, we are learning how to deal with dimensions and significant digits through an example problem related to stress and strain calculations. Note that similar thing is true not only for stress and strain, but also for all future calculations in the field of mechanical engineering. So, you should have a clear understanding of this topic. Problem. There is a round bar with a diameter of 10 mm and a length of 200 mm. A load of 5 kN is acting on both ends of the round bar. The Young's modulus of this load is 210 gigapascal. Then, find the vertical stress, vertical strain, and elongation of the bar. Assume that the stress and strain in the bar are uniform. When a diameter or length of an object is given, in general, in the field of mechanical engineering, we are supposed to use the length in millimeters, not meters. Imagine that you are visiting a workshop and then asking somebody to cut a metal plate. You may say, please cut this plate into a piece of 100 multiplied 400 millimeter. Practically, how to deal with dimensions may vary from field to field. Surprisingly, some fields seem to be using inches, but if we start talking about this issue, we may get confused. Anyway, in the field of mechanical engineering, when you calculate something, you need to, first of all, translate all units into meters. For example, 10 multiplied 10 to the minus cubic if it is 10 millimeter. The force is 5 kilonewton. Here, kilo, the cube of 10. So, it is equal to 5,000 Newton. The Young's modulus is 210 gigapascal. Here, giga means 10 to the power of 9th. Please collect these units and then perform the calculation. I want you to be able to perform this level of calculation without using a calculator. Now, let's think about significant digits a bit. It is, for example, the treatment of circle ratio, pi. In the exams, sometimes students ask which number should be used as circle ratio, pi, for calculation. But I think this question is not suitable in university subjects. In the idea of university level, circle ratio pi should be as accurate as possible. You might think that is a little strange. Why cannot it be 3 digits or 4? What I mean is, you need to put as many digits as you can. In other words, put enough not to influence the answer. Well, it is a bit strange for me to say this, but usually it should be 3 significant digits for problems in mechanical engineering. In physics, we are often told to match the number of digits to a given physical quantity. But in the case of mechanical engineering, it is usually 3 digits. So, for example, 500 megapascal or 311 megapascal or 10.5 gigapascal. You need to use numbers of enough digits so that they can assure these 3-digit value. With pi of 3.14, the last 3 digits may change depending on the number of digits. So, if you use 3.1415 or more digits, it should be usually fine. If you can use a calculator, there is pi in the calculator, so you may use it. From now on, when you are involved in research and design, you have to enter as many digits as possible for pi. It may be 10 or 11 digits. That is the way it should be. Can we use 3.14 for pi? It is not the point. You should use accurate value of pi as much as you can. Similar argument appears for the bottom of the natural logarithm. For example, it's called the Napier number, which is about 2.718, right? I am talking about this kind of thing. You should put in as many digits as you can if you need. In this case, we use pi to calculate the cross-section area of the circle from the diameter. You can then calculate with enough digits to assure the accuracy of your answer in 3 digits. The answer is written below. You can just check if the answer agrees with this or not.